You probably have heard about OpenTelemetry. You understand the concept, but you don't know where to start, what to instrument. So if you're planning to instrument your application utilizing OpenTelemetry, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the OpenTelemetry series. In fact, we already did one episode introducing OpenTelemetry, where I explained the concept, the tooling, the SDK, and so on. Today, we will be focused on how to instrument your code utilizing OpenTelemetry. This episode will be covered in two distinct parts. So part 1, sharing best practices related to instrumentation. Part 2, we will deliver a technical tutorial where we would show how to instrument your code mixing manual and automated instrumentation. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode, the part 1. So we'll start with a brief introduction, and then we will move on by showing the differences between manual and automated instrumentation. We will cover a few best practices on how you could instrument your code. Last, we will do an interview of one of the core contributors of the OpenTelemetry project, and I'm referring to Yoshi Yamaguchi from Google. To have a good understanding on where we are spending time and how our application is currently working, I think we all understand that utilizing OpenTelemetry will provide the right level of details that we are looking for. OpenTelemetry is a framework, specification, set of tools that will help us to collect traces, metrics, and soon logs. To generate traces, we have several ways of doing it. We have the manual instrumentation and we have the automated instrumentation. We clearly understand that instrumenting manually our application will be time-consuming, and we will have to adjust our code adding those manual instrumentation. So the question is, if there is an automated instrumentation library, why should that add more complexity to my business logic, to my code, by adding this manual instrumentation? In order to answer to this question, let's see what we are able to get from the automated instrumentation. So, what does the auto instrumentation mean? Well, the instrumentation library is clearly injected during the code execution. It means that we are attaching to our application a third-party library that will inject, if you take the example of Java, it will inject bytecodes to collect desired traces. Auto-instrumentation is not magic. It will only focus on instrumenting well-known frameworks. It means that if you are planning to instrument your own code, you have to figure out if your framework is currently supported by the automated instrumentation library of OpenTelemetry. Similar to commercial or enterprise observability backend, the instrumentation relies on agents. Agents are great, but it's usually highly dependent on framework language support. So you will need to have one specific agent for each language of your application. Keep in mind that an agent is always a source of concern due to the overhead added by the automated instrumentation library. Most of the commercial agent has very small footprint, but if we go back to the past 10 years ago, few agents of the market were making our application even slower. So we were not able to utilize our application. As a consequence, we were removing those agents from our critical application, or we were only enabling this library for a small portion of our system. If you want to know which framework is supported, so here is the list of the various language and framework of the market. So as you can see, the most popular framework of Java, Python, Node.js, and C# are pretty well supported. So before starting instrumenting your application, you clearly need to check if your framework is supported by the OpenTelemetry instrumentation library. In the future, the OpenTelemetry community want to make sure that automated instrumentation is the preferred option. Why? Because first, it will increase the adoption, and secondly, it will reduce the cost of instrumentation. For now, depending on the framework, the level of details provided by the library, maybe the instrumentation could match your requirement. But if it don't, then you will have to utilize the manual instrumentation. Starting the journey in instrumenting your code is often complicated and is a challenging step. We usually have a lot of questions in our mind. What should I do first? Or how do I know if I'm doing the right thing? Where do I finish this instrumentation? Well, I think everything is a matter of priority. At the end, we want to generate traces to be able to troubleshoot, to understand our system. So when we start instrumenting, we'll need to first focus on one, API calls and operation that will clearly impact our business, our users. If we have well-known performance bottleneck, then we will focus on operations that are called the most often and that are clearly slowing down our system. To cover API calls, we could be smart and simply utilizing the tracing capabilities provided by our service mesh. We had a dedicated episode on service mesh and especially on Istio. Remember, Istio has a tracing capability. The service mesh will generate spans for each upstream and downstream API service call. This source of information is crucial because it will help us to build a dependency map, first of all, and identify potential network issues between our services. Once we have enabled the tracing in our API calls, we want to make sure to track interaction with our storage. I mean, we usually store data in database, in external storage, and so on. So this part, in fact, could be easily done by utilizing the automated instrumentation library that will technically interact with our storage to store. So, as you've seen, most of the framework that interact with the database is supported. And if you've seen our episode on the SQL commenter, remember, you can also utilize the SQL commenter to even get traces from your database code. Once we have a good understanding on the most important components of our application that help us to drive our business, then we want to start adding manual tracing to the most important process. Of course, make sure that the components that you're planning to instrument are stable enough. We don't want to waste time rewriting our instrumentation process. To increase the level of details, we could also implement the following approach. I mean, we know that we are all doing testing. So unit testing, functional testing, performance, and so on. All testing are now mainly happening at early stage to detect problems as early as possible. So we could take advantage of our tests to make sure that the generated traces are always attached to tests. So if we have issues, bugs related to our test, then we will have enough details to help us to troubleshoot and resolve our issue. If we see that there is a process that doesn't have the right details of instrumentation, then no worries. We add the instrumentation to our process and then we rerun our test. With this process, we will have an application having the minimal level of tracing for our production environment. Of course, keep in mind that you will have to continuously improve the level of tracing. We could even come up to a sort of tracing coverage of our application, where we could, for example, we could count the number of requests having spans versus the total number of requests. So this is, of course, only makes sense if you utilizing HTTP communications, but if you use other type of communication, you could utilize other KPI to calculate a similar type of ratio. Our CI/CD system is utilized to trigger our tests, to deploy, and so on. So we could add to our CI/CD process a task that will track the code coverage of our tracing libraries, and we will be able to compare at the end the traces from one release to the other. So if you have any regressions or if you want to improve, by looking at the traces, you will be able to validate the newer or the new version. Make sure to design your traces with enough detail, but don't go on the other side in extreme tracing. I mean, if every method generates spans, the generated traces will be potentially very difficult to view and to be consumed in our observability backend. Similar to login, we can even imagine like a sort of verbosity of our traces. Say I have the level debug, info, error, and so on. With this, we can easily enable a higher level to get more details in case of a major problem. Last, very important, to report errors. And it's crucial, errors is very important. It's going to be very crucial to make sure that you report or you update the state of your spans as errors. So if you instrument manually, make sure to set the trace state to error on every of your try catch. In order to get the best practices of the industry, I would like to call an OpenTelemetry expert, and we will be able to take advantage of his knowledge. He will probably share some advices and recommendation. I would like to call one of the core contributors of the OpenTelemetry project, and I'm referring to Yoshi Yamaguchi from Google. Hi Yoshi, how are you?
Hi Henrik, how are you? I'm very fine, thanks. Thanks for inviting me here.
You're more than welcome, and we are very excited to have you on the show. We all want to get your recommendation related to instrumentation. In fact, we are currently doing an episode on how to instrument your code using OpenTelemetry. We cover a few aspects, but I think it would be awesome to get your expertise. Before we jump into the main topic, could you introduce yourself to the community?
Hi, my name is Yoshi Yamaguchi. I'm based in Tokyo. I'm a developer advocate for Google Cloud Observability things. So not only for our product, but also industry standard open source projects such as OpenTelemetry.
You are one of the contributors of the OpenTelemetry project. Could you remind us in which areas you are contributing?
Yeah, so before starting introduction of my position in OpenTelemetry, let me introduce my relationship with the OpenTelemetry and before that. So when I joined the Google Cloud Developer Advocate team, I was involved with OpenCensus project, which is the ancestor of OpenTelemetry. And after some contribution to the OpenCensus, I started contributing to OpenTelemetry because it has a lot to do with OpenCensus. And I have written some sample codes and and small patches to OpenTelemetry for Go in the very first phase. And after we opened up a new team inside Google for OpenTelemetry, I stepped out from the actual contribution to the OpenTelemetry core, but I started out our local community effort in Japan. So now we are translating the all spec of OpenTelemetry into Japanese, so that the Japanese developer can understand the details of OpenTelemetry these days. And also internally, I'm working on the bridge between OpenTelemetry and our proprietary product, such as Google Cloud Logging and then Google Cloud Monitoring and Logging and Traces.
When you mention connection with Google Cloud Trace, do you mean building a Google Cloud Trace exporter for OpenTelemetry?
Yeah, I have written very first implementation of exporter for Google Cloud Trace, and I have writing up more and more advanced use cases with OpenTelemetry and Cloud Trace these days.
We did an episode on a SQL commenter, and we were using the Google Cloud Trace exporter, so it means that you were also involved in the SQL commenter project.
Yeah. So that I can write end-to-end trace example, I have contributed to SQL commenter as well, as you said.
In this episode, I try to share some best practices for the community, because instrumentation could be considered to be a bit expensive for most of the developers and projects. Do you have any best practices? Where or how should teams instrument? How should they start instrumenting their code?
And then my suggestion. This is my personal view. So other people may say different thing, but my recommendation is to write small instrumentation, manual instrumentation with the OpenTelemetry first. That the reason why is because it gives you the idea of how the OpenTelemetry works internally. For example, creating the trace provider and then set everything to the trace provider and then set exporters and then create trace and then create spans, etc., etc. So now and after you instrument the whole thing, then you understand how the OpenTelemetry works for like trace instrumentation. So you don't need to do it for production code. You just can do it with a small sample, like a single API. And then after you get the idea of how OpenTelemetry works, then I really strongly recommend to use auto instrumentator if it's available for the specific product. For example, in the case of Python, there is an auto instrumenter for Flask. So if you're using Flask for API server, then you get everything for traces. So it's really easier for you to have the instrumentation for trace. So that's my recommendation. And also another recommendation is to utilize collector as much as possible, because it reduces the amount of exporter connection to the backend, and also it gives simpler architecture for sending traces, the spans to the backend. So though it's under development, active development, and then it's not fully functional for like metrics and others, but it works for traces. So if you can use collector inside your system, then I strongly recommend to use it.
When instrumenting, we need to use specific OpenTelemetry object. I know that there are different type of span processor and various type of sampler. When we start instrumenting, we obviously want to use batch processor or maybe simple span processor to make sure that we are sending most of the telemetry. Then in terms of sampling, we probably want to get as much trace as possible, but then we will probably realize that it has a significant impact in terms of storage and also in terms of how we can utilize those traces once they are stored. Do you have any recommendation for developers on which span processor and sampler they should use without impacting the storage?
Yeah, I personally only use batch span processor, because in my use case I only create the samples, and then regardless of the size of sample, so I don't need the real-time traces on a backend. So I'm fine if I can get the trace eventually. So batch processor reduces the CPU usage for sending traces to the backend. It helps in the case of production code. So I only use batch span processors. For sampling, I start using always sample option first, because I want to check if the code is working fine. After confirming the span is available as expected, then I try to tweak the probable sampler so that we don't consume the backend disk space too much. So that's the thing, and it's really hard to tell the best probability of the sampler, because it always depends on the situation. So if you reduces the number of sampling, then the probability to miss the important trace is get higher. So it always depending upon the cases, but I start from 0.5 because my use case is the number of the requests is always small, so I start from the 0.5, and if I feel the amount of the traces is bigger than expected, then I start tweaking the number to the smaller ones. So the important thing is that you don't get the exact number by the first implementation, so you need to adjust the number, the probability of sampling as you operate the system.
So it means that we should not improvise or try directly in production. We should first try in a testing or staging environment, even probably do a small POC. So change the tracing configuration, like the span processor and the sampler. Measure the impact of your settings in terms of storage and trace usage. Make sure to test with significant traffic. Remember, with traffic you'll have more trace, so you need traffic. So probably combining load tests would be a great way of testing the setting. In this episode, I used the Auto Instrumentation library that generates lots of details on the usage of our framework. But sometimes there are few methods that are not instrumented. So I had in the tutorial to utilize manual instrumentation. I suggested to the community to start first with the automated instrumentation library and then add manual tracing on the important methods or API call. Everything that is considered important for us needs to be traced. To track the level of tracing, I also suggested to have a tracing coverage score that could be calculated in our build process. We could track how much code has been traced. Do you have any suggestion on how we could calculate that type of ratio?
Actually, I seldom thought about it, and every time I try to calculate the number in advance, I just roughly calculate it based on the number of the important components inside the system per total request. maybe it's easy to calculate or estimate the number of requests based on the historical data. And it is also you can check the important component per request based on the source code you have. So I always try to calculate the number of total spans based on those numbers, and then roughly calculates the number of the data, amount of data sent to the backend. But I do not have more detailed number. So if you know, then I'd like to know it as well.
I like your idea of projecting the number of spans that we should produce by looking at the most important requests versus the total number of requests. With this projection, we could then configure out an expected tracing coverage of our code, and then we could calculate our current tracing coverage to see if we are far from our initial target. For microservices architecture, I suggested to use the number of requests having spans versus the total number of requests. Then, like you mentioned, at the moment we don't have any scientific calculation or formula to get that type of ratio. But let's come up with a formula that could help our community. So if you have any suggestions or idea, please drop a comment in this video. So we talked about tracing so far, but the OpenTelemetry project has made lots of effort on supporting metrics, and now logging is currently in development. When it comes to metrics, how would you recommend to push metrics using OpenTelemetry? Do you have any feedback on the usage of metrics?
So the status of metrics is a bit complex. So OpenTelemetry consists of a couple of components. The first one, really the bottom one, is spec. So every single instrumentation should follow must follow the spec. Once spec is fixed, then every implementation happens. So API and SDK are implemented based on the spec. After the implementation of API and SDK, then other stuff follows, such as the exporters or collector related things. And the status of metrics now is that the spec of metrics is GA, so it's okay. And API and SDK are under implementation, or in some languages it's already GA. And then exporters are not ready yet, as far as I understand. So, but still, I mean, it's not ready yet means not GA. So it's available, it works, but it may have breaking changes until the GA. So if you want to try OpenTelemetry metrics, then you can try it out today, because there is working implementation in a repository. So you can just check out to your code and then just use it in your code and then build it, and then it works. For main languages such as Java, .NET, and Go, and I think it works for Python as well. But you will experience the breaking changes in the near future, because the exporters in each languages are actively updated for GA, so it includes the breaking changes. So if you are okay with catching up the breaking changes, then you can use the metrics thing for OpenTelemetry today. But if you are like in charge of some mission critical production code, then I don't recommend to use it now, because it's going to have breaking changes in the near future until GA. And GA is expected to be sometime in this half, I mean 2022 June, maybe, for many languages. So my recommendation is to keep eye on the updates of OpenTelemetry for metrics and try playing around with it so that you can be ready when the OpenTelemetry for metrics to get GA.
In model tracing, do you have any recommendation when adding extra information has the span attributes or attributes with the events or bagage?
So for traces, I try to put the event specific information to the event, but if the context is more like environment specific ones, like such as runtime information, then I try to put it attribute. So everything always has to do with the storage as well. So the more you have, then the easier to analyze. But like it's hard to maintain. So it depends on how much you want to have. I mean, how much information you want to have for analyzing the application issues. So my suggestion is to put as much information as possible to the single telemetry, but if it will become a cause of the operation problem, then you need to think about reducing useless information out of it.
Could you share the latest news related to the OpenTelemetry project?
So as you mentioned, the logs is the most exciting one for me. At least I think the spec of logs are mostly done for GA, and now the logs 6 teams are actively working on the implementation of those. Because OpenTelemetry logs are mostly from Stanza, which was developed by ObserverIQ team. So there is a working implementation already. So if you want to try OpenTelemetry for logs, then I think you should check it out today. And also other thing I come up with is that Google recently donated SQL commenter to OpenTelemetry organization, which enables developers to add SQL comment with trace or other trace information. So if you use it, then you can have end-to-end trace. So it gives you more context or more information on the latency, like such as slow query and so on. So if your application is heavily using database, then I strongly recommend to try out. SQL commenter is one of the expansion of OpenTelemetry ecosystem. So if you haven't checked SQL commenter yet, then please check it out. The only problem today is that the version of OpenTelemetry used in SQL commenter is not up to date. So SQL commenter team is actively working on updating the depending OpenTelemetry libraries, but still it's usable, and it gives you a new idea on how to utilize OpenTelemetry better. So if you haven't checked it out, then just go to the library, go to the repository, and then please try it out.
Thanks a lot for your time, Yoshi. If I have another topic related to tracing or the usage of OpenTelemetry, I would love to have you back on the show.
Yeah, I'm pretty much looking forward to any suggestions or feedbacks to this episode.
All right, thanks so much, and see you soon. Bye.
Yeah, have a good day. Bye.
That's it for today's episode related to the OpenTelemetry instrumentation, the part 1, where we shared you best practice and we had the honor to interview today Yoshi Yamaguchi from Google. If you're looking for the tutorial, be patient. The part 2 will be available soon and we'll go step by step on how to attach your instrumentation library and how to manually instrument your code. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So thanks for watching and see you soon.